Alright. Good day, scholars. Let me my humble self, Mr. Garamala. Alright. Alright, scholars, it's nice watching this funny note with us together. Okay, our quote of the day. Alright. And the objective of today's class okay. And these are keywords: tangent, circle, circumference, radius, angles. Alright, let's sit back and take a look at this video.
Hey there everyone, and welcome back to Mashup Math. My name is Anthony, and thank you for joining me on this mini lesson. Just go ahead and check it out. Hey there everyone, thanks again for joining me on this lesson where we are going to explore the relationship between circles and tangent lines. So let's start with the question, what is a tangent line to a circle? So let's take a look at a circle with a center at point P. And let's also imagine another point on the circle, and we'll call that point T. A tangent line to a circle is a line that intersects the circle at exactly one point, in this case, our point T. Now, if we construct a line that connects that center point P with that point T on the outside of the circle, we would be constructing a radius, and we can call that line R. So PT is a radius of circle P. And if we look at the angle created by the radius and the tangent line, we should see that this appears to be a right angle measuring 90 degrees. And this is the case with tangent lines and circles. And we can say that a tangent line is perpendicular to a circle's radius. So if we add another point on the tangent line, point J, we can conclude that angle PTJ has a measure of 90 degrees. And this perpendicular relationship between a circle's radius and a tangent line applies to every circle in any occasion. So the key concepts to understand here is that a tangent line intersects a circle at exactly one point, and that a tangent line and the radius it intersects are perpendicular.
Cool.
So now let's go ahead and apply our understanding of tangent lines and circles to a practice problem. In this case, we have line segment UT and line segment UV both being tangent to circle O, and we're looking to find the value of x shown on the diagram. So notice that lines UT and UV are line segments. However, they are still tangent to circle O, which means that they will still hold the same properties of tangent lines even though they are not infinite lines. And we should also note that we know that angle O has a value of 121 degrees, and that angle U is the value x that we are looking to find. Now we know that UT and UV are tangent lines to circle O, and we know that a tangent line is perpendicular to the radius it intersects. So we can conclude that angles T and V are right angles and have measures of 90 degrees. We should also notice that we are dealing with a quadrilateral here in this diagram. And we know that the sum of the interior angles in any quadrilateral is always equal to 360 degrees. So if we take these four angle measures and add them together, their sum will equal 360. And we can use this fact to find the value of x. 121 plus 90 plus whatever x is going to equal 360. And now we can just use some basic algebra to isolate the value of x and find out its value. In this case, adding the three angles that we do know gives a value of 301. Subtracting 301 from 360 results in 59, which is the value of x, and we can conclude that angle U is 59 degrees. So now that you understand the properties of tangent lines and circles and have got some more experience applying those relationships to practice problems like this one, you can continue to apply your skills and understanding to future problems. So thank you again for stopping by, everyone, and I'll catch you soon.
Cool.
Alright, so that's it for this lesson. Thank you again for stopping by. I hope you found it helpful. And if you did, please click that link below and subscribe to our YouTube channel.
Right, scholars, let's look at more example. This is a past question. Read through the lines appropriately. Alright. And we're asked to find the value of x, y, and z. Let's take a look at the solution. To find y from the previous video, PT is tangent to the circle. So the distance from P to the center is radius and the angle is 90. So therefore y is 90 minus 54 degree, which is 36 degree. And to get your z or your z from the theorem of angle at the center of a circle is twice the angle at the circumference. So therefore, since we have gotten y as 36 and the triangle there is POQ, which is an isosceles triangle, so the base angles are equal, so we'll get the obtuse angle as 108, and when you divide it by 2 you get your z, which is 54 degree. And also z is alternate to angle TPQ if you don't want to go through the first process. And to get our x, we have 180 degree minus 108. How do we know? Angles in a cyclic quadrilateral. Right. Did some activities for us. We are to do this. Take a look at the question, read through the lines, and solve these 4 questions for the next 4 minutes. You should be able to finish it in the next 4-5 minutes, thereabout. And when you are done, you have the mark scheme. And these are the mark scheme for each question. Let me go over again. Then we've come to the end of the lesson. If you have any question, go through the YouTube video over and over again. Take your text material and go through the topic from your textbook. If you have any question to ask, deem it fit to post it on the Edmodo platform. Then I will make clarification on the question. So at the end of this lesson, you should be able to describe angles, tangents to a circle, and calculate unknown angles on tangent to a circle, and link up the solution from the other theorems you have learned. Alright, what to expect from our next class? In our next class, we'll be starting a new topic which is under sequence and series. The below YouTube video or link will be useful. So go over and start reading up. Have a wonderful day. I love you. Stay safe. Have a wonderful day, scholars. See you next time.